Okay, in this video we are going to talk about the derivative. So this is basically the first video for the derivative. Okay, so we will talk some introduction of the derivative. I will review on the slope of a line, and then I'll give you the definition of the derivative, and we'll do some more examples. Okay, so first of all, let us look at this figure. This is x-axis and the y-axis. This green curve is fx, okay, f of x. You see that? And at this green curve, I consider a point P whose coordinate is x comma y. So if this coordinate is x comma y, so this distance must be x, right? And then that distance must be y. You see that? And little right on the x, that means about delta x distance from x, that I consider another point. So little further right from the point P, I consider another point Q. Suppose that the distance between this x and that point, the distance is delta x. So this whole length will be x plus delta x, right? Because this length is x. You see that? That length is x and this length is delta x. So the whole total length is x plus delta x. Okay? And suppose the height at the point x plus delta x, the height of the function at the point x plus delta x is y plus delta y. So the coordinate of this point Q is x plus delta x, comma, y plus delta y. So what is the slope of the line joining PQ? So we call PQ is a secant line. Why we call secant line? Secant line is a line that intersects a curve at 2 points, okay, or more than 1 point. So this is a secant line, okay. So the slope of the secant line is, it is like, you can think this has like x1, y1, and this has like x2, y2, right? How do I find out the slope of a line? It is y2 minus y1 over x2 minus x1, right? So you do y2 minus y1 over x2 minus x1 equals to, what is y2 minus y1? It is y plus delta y minus y1 is just y, right? Over, it is x plus delta x minus x. You cancel out that y and negative y and positive x and negative x. So what do you get? You got delta y over delta x. You see that? So basically what you can think that a different way too, because this is delta x, right? This length is basically delta y. So this is basically the ratio of rise over run, because when you go from the point P to the point Q, then the rise is delta y and then run is delta x. So you can think that way too. So basically the slope of this secant line is delta y over delta x. The slope of the secant line is delta y over delta x. Let us do something different here. What I want to do is, I want to decrease this length delta x. If I decrease delta x a little bit, so how does it look like? If you decrease that delta x a little bit here, and that point Q will move this point, right? And then your tangent line, your secant line will look like this. You see that? When you decrease the value of delta x. Similarly, if you decrease the delta x right here, let me use different color for that. If you decrease the delta x a little bit more, then that point, that line, the secant line PQ look like that. You see? Similarly, if you move the point delta x somewhere here, then how does that look like? Then that secant line basically look like a tangent line. You see that? The PQ line. So when delta x tends to 0, meaning when you make delta x small, small, and small, then x and x plus delta x will be almost the same point, right? At that time, then the secant line, then the secant PQ becomes a tangent line at P. You see that? This is the point P. The slope of the tangent line at P, in that case, will be m equals to, so it is limit delta x tends to 0, meaning we are taking delta x very small, right? Which is exactly the same slope, because that point is xy and that pink point will be x plus delta x, y plus delta y, right? And the slope will be exactly same. So it will be delta y over delta x. This is the slope of the tangent line. Okay, so in terms of x and f of x, so if you write this as using f of x, so x is the x, right? Y is f of x. You see that? You can write this as x comma f of x. That is x comma y. So this point will look like x plus delta x and then comma f of x plus delta x, right? You can write that way too. This is just another way. So y plus delta y can be written as f, meaning that height is the f, right? F x plus delta. So height at x plus delta x. That's what it means. So you can write exactly the same thing as f of x plus delta x minus fx over delta x, right? How did I get that f of x plus delta x? I can make you another figure to show just that thing. So basically what is happening there is basically look at this. This is the point P, right? So what is the coordinate of that point P? So it is x comma fx, because y is fx, right? This is x. So the name of the curve, the equation of the curve is just y equals to f of x. Now this is delta x, right? So what is the coordinate of this point? It is x plus delta x, right? So what is the height of that function at that point? It is like q, right? X plus delta x comma f of x plus delta x. That is basically, f is basically the height, right? So height at f plus x plus delta x. That's what we are doing. So if you write that way, then it is basically when you move that. So in other words, you can do like this. So this is delta x, right? This will be, how much is that length? This is fx. This height is fx, right? And then this, the total height is f of x plus delta x. So this, how much is that one only? So it is basically f of x plus delta x minus fx, right? And this is delta x. So you can write that way too. So it is exactly the same thing. So how can you find the equation of the tangent line then? Equation of the tangent line can be found as limit delta x tends to 0, change in y over change in x, or delta y over delta x. Or another way of saying the same thing, exactly same thing, is limit delta x tends to 0, f of x plus delta x minus fx over delta x. So this is another way of writing the slope of the tangent line at a point pxy. Okay, so this is basically the slope of the tangent line, slope of the tangent line at px comma y. This is, or you can, oh, I wrote the same thing here, px comma y. So this is basically, this formula give you the slope of the tangent line. You can use either of those two formula, or either delta y over delta x, or limit x delta x tends to 0, x plus delta x minus fx over delta x. If you are worrying about why do we use delta x, why not a simple notation? Delta x is a small number. Just delta or just x doesn't make sense here. It is delta x is one single quantity, because delta x is the length from x to that point. Okay, so delta x is a single quantity. You can write just h instead of writing delta x, you can write h. So in that case, the formula will be limit h tends to 0, right? And then f of x plus h minus fx over h. You can do that too. So it is perfectly fine. Okay, let us define the derivative of a function. So the derivative of a function at a point is basically the slope of the tangent line. Okay, so the derivative of f of x at x comma y is, we denoted by you, sometimes we denote by f prime of x, or we denote by dy over dx. Some people denote like that too, or some people denote like y prime. Okay, these are the all notations we use for the derivative. Okay, so but the formula is, and given by f prime of x equals to limit delta x tends to 0, f of x plus delta x minus fx divided by delta x. So this is the formula of the derivative or the slope basically. So slope of the tangent line at a point P and the slope of and the derivative of a function at that point are the same thing. Okay, so f prime of x equals to limit f of x plus delta x minus fx. So this is plus. Okay, so x plus delta x minus fx over delta x. If you want to find out the derivative at x equals to a number like x equals to c, then we denote by f prime at c. We read like f prime of x or dy over dx or y prime. That little dash is called prime. Okay, so f prime of c equals to limit delta x tends to 0, f of c plus delta x minus f of c over delta x. Basically that x will be replaced by c. So we will see some more examples, but before we do the example, let me tell you something about the slope. Okay, if there is a line, then slope is the slope of that line, meaning that any point, if you pick any point, you will get the same slope. So if you find the slope of this section or that section or that section, you will get the same slope. Okay, if it is a line. But if it is a curve, slope means the slope is different because it is decreasing here. The slope is negative, right? It is not neither increasing nor decreasing at that point. The slope is 0. So it is increasing here. The slope is positive. So how do I find out the slope of a curve? That is basically, to find out the slope of the curve means we find the slope of the tangent line at each point. For example, at this point, we draw a tangent and find the slope of that tangent. At this point, draw a tangent, that's the slope of the tangent. At this point, draw a tangent and find the slope of that tangent. And similarly at all other points, meaning that in case of the curve, slope means slope at a point. Okay, slope at a point. And how do I find out that? To find out slope at a point, what we do is we basically find out the slope slope of the tangent line at each of the point. That's what the slope means for a curve. Okay, so for a curve, slope changes at each point. Okay, all right, so let us find out the derivative by using that definition of the derivative. Let us find out the derivative of the different function and we will derive a formula. Okay, let's find out the derivative of this function. We will find out f prime of x if fx equals to x. So solution is, what is the formula for f prime of x? The formula is limit delta x tends to 0, right? F of x plus delta x minus f of x divided by delta x. Now tell me, what is f of x plus delta x? See, fx is x, right? So if you want to find out f of x plus delta x, then that x will be replaced by x plus delta x. So that x will be replaced by x plus delta x. That will give you, let me write down the limit delta x tends to 0. That will be x plus delta x minus f of x is basically x divided by delta x. You see that? Now this is basically negative delta x and positive delta x cancel out. So what is left is delta x over delta x, right? So you cancel out. So this is basically 1. So how do I write that then? So the f prime of x is basically 1. Meaning, if the function is just x, then the derivative is 1. Okay? So let us do another example. If f prime of x, find f prime of x if fx equals to x squared. So in this case, what we do again, f prime of x, we use the formula limit delta x tends to 0, right? F of x plus delta x minus f of x, right? Divided by delta x. Now what is f of x plus delta x? You just use that function, right? Replace x by x plus delta x. So you will get limit delta x tends to 0. It is x plus delta x square minus x square. You see that? Divided by delta x. Now how do I simplify the top? You simplify the top by foiling that, right? You foil the top. It is like x plus delta x times x plus delta x. So how do you do that? It is like you see that x plus delta x times x plus delta x, right? So how much would that be? So it is x squared plus x times delta x plus x times delta x plus delta x square, right? So it is x times delta x times delta x will be 2x times delta x. You see that? So let me write down that. It is like x squared plus 2x times delta x plus delta x square. minus that x square is just x square. You see that? Divide by delta x. Now you see that this negative x square and the positive x square cancel out. That negative x square and the positive x square cancel out. So what is left there is limit delta x tends to 0. So that what is left in the top is 2x delta x plus delta x square, right? Now let me factor out that delta x from the top. So if you take that delta x out, you're left with 2x plus delta x divide by delta x, right? Now you cancel out those delta x and delta x because they are dividing, right? So what is left is basically limit delta x tends to 0, 2x plus delta x, right? Now plug in the delta x limit as 0. So this will go to 0, right? So what is left is 2x. Okay, now look at this. So the derivative of x is 1. The derivative of x squared is 2 times x. So can you guess what will be the derivative of x cubed? So the idea is this, okay? So how do I guess that is, if the exponent of the x is 1, okay? If the exponent of x is 1, x to the 1, then the derivative is 1 and then x to the 1 minus 1. You can generalize like that because what is x to the 1 minus 1? It is x to the 0, right? So 1 times x to the 0 is basically 1 times 1 because x to the 0 is 1. So 1 times x to the 0, that is 1. If there is x squared, then you can think that way. So it is like the derivative will look like the exponent comes to the first, like you have here, the exponent comes to the first and then you write x and then exponent minus 1. Here exponent comes to the first and then x and then exponent minus 1. Look at that. 2 times x, 2 minus 1. How much is that? That is basically 2x to the 1, right? That's just 2x. So similarly, if you have fx equals to x to the cube, then if you do exactly the same technique, you will have x plus delta x to the third minus x cubed divided by delta x, and then you do you fold that, you multiply 2 times, right? X plus delta x times x plus delta x times x plus delta x 3 times, like that. If you fold that, you will get like this. Because there is 3, it is like the 3 goes to the first and then you write x and then 3 minus 1. That will give you 3x squared if there is x to the cubed. Okay, how about x to the n? For any exponent n, the derivative will look like this: nx n minus 1. That is the derivative of x to the n. We call this as a power rule. Okay, so basically you can write exactly same thing. Instead of using fx, if the question is given like this, like say y equals to x to the fourth, what will be the y prime? Exactly the same, right? Because instead of y, instead of f of x, I'm writing y. If there is x to the fourth, how much would be the y prime? That is the derivative. It is same as f prime of x. It will be 4 and then x, 4 minus 1. That will be 4x to the cube. So you can use this power rule to find out the derivative of any function. Okay, so I want to give you one couple more examples actually. So this example has more than one terms. Instead of just x and x squared, we have more than one. There is x squared plus x minus 1. But I want to use limit definition for this, or we call limit process. The method of doing this, writing limit delta x tends to 0, that definition is called limit definition or limit process. Okay, so to find out the derivative of this function, what we want to do is just use the formula, because it asks use the limit definition, right? So how do I use the formula? Solution is what is f prime of x? The formula is limit. I can write h tends to 0. Okay, instead of delta x, I can write h tends to 0. There is not a problem. Exactly the same way. Instead of x plus delta x, I am writing h minus f of x divide by h. You can write that way too. If you don't like to use delta x, you can use h. That is perfectly fine. So what is f of x plus h? Limit h tends to 0. F of x plus h will be, replace x by x plus h, right? It will be x plus h squared plus x plus h, right? Minus 1. That is f of x plus h minus what is f of x? It is x squared plus x minus 1 divide by h is there. Now what we do, you FOIL that x plus h square and then just simplify that. Okay, so I can write this as limit h tends to 0, x plus h square will be x plus h times x plus h, right? So how do you do that? It is like you can write that scratch as x plus h times x plus h, right? How much is that? It is x times x is x square. It is just foiling, right? X square, x times h is xx plus xh plus h times x is xh plus h square, right? So you can write x square plus xs plus xh is 2xs. So you can write this as basically x square plus 2xh plus h square, right? And you distribute that positive sign to x and h plus x plus h minus 1, and then again you distribute that negative sign here, negative x square minus x plus 1 divided by h. Okay, now how do you simplify? You cancel out that positive 1 negative 1, right? Also you cancel out negative x and positive x. Also you cancel out negative x square and positive x square. So what is left there? You are left with limit h tends to 0. There is 2xh plus h square, right? You can factor out h. If you factor out h, you will get 2x plus h plus 1, right? Because there is one more term. You see that? Which are the terms left there? This is one term left, that is another term, and that is another term. You see that? So divide by, you see that is h, right? Now you cancel that h and h. So how do I cancel that? You cancel that h and h. So what is left is limit h tends to 0, 2x plus h plus 1. Now you plug in h equals to 0, right? So when you plug in h equals to 0, you will get 2x plus 1. So this is defining the derivative by using the limit definition. Okay, this is finding the derivative by using the limit definition. Now the question is, if you use that power rule formula directly, would you be able to find out that, get that answer? Yes, absolutely yes. Why? Because you see that what is the derivative of x square? The formula says the derivative of x square is 2x2 minus 1, basically 2x, right? The derivative of x square is 2x. What is the derivative of x? The derivative of x square is 2x. The derivative of x is 1, right? So 2x plus 1. The derivative of 1 is 0. Why is that? The derivative of a constant number, it can be 1 or 2 or 3. If there is a derivative of a number, it is always 0. Why? Because you can use that formula. Again, you can use this power rule formula. Let me show you how can I use the power rule formula to find out the derivative of a constant, right? So suppose you want to find out the derivative, y is say 1. Okay, so how do I find out y prime? If 1 is basically, how can you write that 1? You can write 1 as x to the 0, right? So how do you do that then? It is like 0 times x times 0 minus 1. You see that? Because if there is x to the n, the formula says nx n minus 1. That's the formula, right? So I'm writing the power times x to the power minus 1. Okay, so what do you get? 0 times 1 over x, right? Or you can write 0 times x to the negative 1. We are assuming that x is non-zero there. So it is basically 0. If there is like y equals to 5, you can write that as 5 times x to the 0, right? So you can write, so y prime will be 5 times, what is the derivative of x to the 0 is 0 times x times 0 minus 1. So it is basically 0. This is basically 0 and the 5 times 0. So if there is just a constant not attached with x, then the derivative is always 0. So we will see that in the next section too. Okay, so let us see some more examples on finding the derivative by limit process.